So this particular course, I will videograph it and give the contents to you so that at any particular point of time you have a doubt and all that, or you missed some classes, you will be able to recollect. Okay, let me start this class like this. I have over 25 years, I have taken or met with the students about 1,500, 1,700 students. So I would say some students are really good, the students which can fall in top 2% slot. So top 2% student, they felt that this particular subject, mechanics of machine 2, is the most difficult thing to handle. Okay? So there is a word of caution that this is the most difficult subject because lot of applications is involved. When I am talking about something, you should know what it is. Otherwise, you will be lost. Okay? So in this subject, you will have answers for many things. If you open up your washing machine, in the drum, you can see a concrete block. Why there is a concrete block in a washing machine? That we will derive and give you the answer. We will also ask the questions. Why concrete block is added in the drum of a washing machine? When you go to a car, wheel alignment, the wheel alignment, they also say that balancing of wheels. They add some small weights to the wheels. So why it is done? What is the theory behind it? So you will also see that when a wind blows, some of the poles, light poles, oscillate like this. So why it oscillates? How to stop it? So you will have answers to that. If you look at the high tension cables, you know, that will be running across the cities. There, if you notice, there will be a small pendulum, there will be a small component like this, which looks like the dumbbell. If you notice, next time you look at it, you will notice this particular thing. Why this is put? You will have answers for that. If you take huge buildings like Taipei 101, there you can see a very large, very heavy ball is there. That ball swings and takes care of the earthquake. So why that ball is provided? Okay? So why IC engines are having in a particular configuration which is popular? 6-cylinder engines. 6-cylinder engines are very popular. Why? So you will have answers for that. So this is a very a course where it is closely interrelated to the applications. So you will have answers to many of these things. Okay? So what are the things that you are going to study? First, continuation of the mechanisms. Okay, so you will have first static and dynamic force analysis of mechanisms. As you know that in the first part, mechanics of machine 1, it was all about kinematics. That is, we study about the motions of these mechanisms without considering the forces that causes. So if you take a definition of kinematics also, it says that the forces that causes this motion are not considered. But while correcting the papers of yours, I found that a beautiful definition an addition to the definition, someone has written that it is force and torque. We don't bother about not only the force and the torque. Okay? So I think it is an addition. So we will change the definition hereafter. Kinematics is study of motions of the bodies without bothering about the forces and torque that causes them. Okay? So that I have taken from you. Someone has written that forces and torque. So here when it comes to the mechanism, what we have done is we have studied about getting the accelerations of the components. But if something is to accelerate, there must be a net force acting on it. Something is angularly accelerating, net torque must be acting on it. We have not talked about it. We ignored it the last semester. This semester we cannot ignore it. We will take into account, and we will do the analysis about the mechanism. We will find out what are the forces acting on each link. So the output of this should go to the machine design subject. So in machine design, you will be given, there is a member like this, and there is a net force is acting. You design a link like this. So by doing this, you are giving an input to your machine design so that you can design your mechanisms and machines. Okay? So you will be doing a static and dynamic force of this. This particular part of this subject or this chapter is taken from a book called Kinematics and Dynamics of Machinery by Martin. So this Martin book, it is given in the syllabus. So that particular part I have scanned. I can send you this copies to you by email. It is better you take a printout and come, because this as we go along, fine points you should be able to note down. If you miss the fine points, your answers or whatever you get up, the final thing will be totally wrong. So we are going to do this. We are going to study the theory of it. We will have at least 1 or 2 drafting session to find out the forces. Okay? So that is the mandatory requirement. So drafting session will not go away. So for this, what is an input? Input is the previous semester. You should know thoroughly how to draw the acceleration diagram. You should know how to find out the acceleration of a point in a link. Okay, so that is an input for this. Then we will discuss about balancing. So balancing of rotating parts and reciprocating parts. So a rotating components or part, what are the theories are involved, how to balance it, then what is balancing, that all we will discuss about this. Okay, so if you take your fan, see some of the fans, if the balance is not proper, they will shake. That fan you see, that is shaking. Okay, it is due to the unbalance which is present in blades. So how to tackle that, how to balance it. Okay, so this is about the balancing. When it comes to the reciprocating balancing, we will discuss about balancing of IC engines, the multi-cylinder engine, single cylinder engine, etc. Then the other part, next thing is about gyroscope. It is definitely not a MEMS gyroscope. We are going to discuss about a regular gyroscope. So what are the uses of gyroscope? What is a gyroscope? So all this we will discuss. We will also play a video from the physics lecture by Walter Lewin. Of MIT. Some of you would have seen this video already, but I say that this is a lecture, very good lecture, to show the various aspects of the gyroscope. Then the other topic is about flywheels. We'll discuss what is the principles of a flywheel, how to design a flywheel for an engine or a punching machine. So these are all various components, various machineries require flywheel. So we will discuss that. Then after this, we come to a very important topic, that is mechanical vibrations. We will discuss about vibrations. I think in +2 itself you have vibrations about lumped parameters, spring mass damper system, how it behaves. So we will derive this free vibrations, then we will have force vibrations, then these are all the fundamental things, where differential equations will be involved. Then we will have our discussion on vibration control. So there you will have vibration isolation, the philosophy of vibration control, everything we will discuss. Okay, so that is another important thing. So here we will concentrate more. So you will have a lot of equations. So some of the equations will occupy the quarter of the board. Okay. So, but we will not be discussing those things. We will go into the equations and how they will affect mechanically. What is the physical meaning of these equations? That is what we will discuss. So these are the summary of the topics that we will be covering in mechanics of machine 2. So wherever possible, we will bring the application. We will see how it is really connected to your day-to-day engineering application. You have any doubts? Very interesting and important thing is, for all this theory that you study, that you can verify in the lab. We have the laboratory, dynamics laboratory, that is also going. Along with this, for many things, you will have the practical exercise that you will do. Whatever theory we teach, that you can correlate. So that is one important advantage that you will get. Okay? So dynamics lab is very, very important. Now let us take the first thing, that is the static force analysis of a mechanism. Okay? So we will say static So we will take the prerequisite for this is you have to review whatever you have learned in engineering mechanics. So if you have forgotten the engineering mechanics fundamentals, please review it. Otherwise it will be difficult. Now let us take a slider crank mechanism. Like this. We know this is O2, this linkage we will say is 2, this we will say this is 3 and this is 4, and you have a ground. This is very familiar to you. Let us take a slider crank mechanism. And these mechanisms need not be always used for transmitting motions. Sometimes it can be used for holding, for static application. For example, you can recall a toggle clamp. You remember the toggle clamp? The toggle clamp, when you hold a toggle clamp, they are not going to move. But since they are holding something, there will be forces acting on it. Here, in the static force analysis, let us think there is a force P is acting on the piston. Or using a slider crank mechanism, you are using this to crush something. Now it is holding something. So that is offering a reaction force of P. But since it is a static force analysis, I will say that this mechanism is not going to move. In ordinary way, if you look at it, when a force P is acting on it, this will be rotating or this will be moving. But I don't want this mechanism to move. It should be in a static condition. That is possible only if you apply an external force to hold it. So we will apply a torque T. So the torque T is called holding torque. So if you apply the torque T here, this will resist this force P which is applied on the slider. The mechanism will be in a static condition. So such a torque we call it as a holding torque. I can say sometimes a force can be holding force. A force can be called as a holding force if it arrests the motion. For example, you are playing with your friend. Say he is having a cycle. You want to hold him. So put your hand and in the carrier and stop him from moving. So he will try to pedal, and you apply the force so that you don't allow him to move. Isn't it? So you don't want him to move, you apply the force on the carrier and stop him. So you are applying a force that stops this from moving. Making this as a static thing, that force applied by you can be called as a holding force. Now there is a fan which is moving. If somebody, so you stop the fan. When you switch on the fan, what will happen? It will rotate, it will accelerate and reach a constant speed. But you hold the blade and switch on. What will happen? The fan will not rotate. So you are offering a torque that resists the motion of the fan, otherwise it would be in motion. So that torque is called the holding torque. Suppose you put your hand on the wheel of the cycle and stop the cycle from moving, then you are offering a torque on the wheels. That will be the holding torque. Don't do that because you may be hurt. The fan also, you have to be careful. Few years back, we had one student called Thirumal. He is the tallest. I think he is about 7 feet. At that time, we were having classes at LH. So I asked him to just climb on the bench and ask him to hold, to show that it is a holding torque. So it was very convenient for him because he is very tall, he holds. He held that fan from moving to demonstrate that it is the holding torque. So, if I apply a torque that resists the motion, makes the thing as a static, that is called a holding torque and or holding force. In our case, this is holding torque. Suppose I am offering a torque here and apply a force speed so that this mechanism is not allowed to move, then we can call that as a holding force. Okay. Now I think you can distinguish what is a normal torque, normal force, and a holding torque and holding force. This holding torque or holding force will make the system as static, okay, which otherwise would be moving. Now, the question is, when a force P is applied on this, what is the holding torque I should give on the link 2 so that the system will be in equilibrium? In the sense it will be in static equilibrium. Okay, so that is the question. How will you find out the holding torque? So for that you have to do the analysis called the static force analysis. So static force analysis essentially requires the construction of free body diagram. So it is free body diagram is very much the engineering mechanics concept which is widely used in your mechanical engineering. Now I ask you to draw the free body diagram of this chair. Please draw the free body diagram of this chair. Yeah, free body diagram of the chair. Then you can consider this as a planar structure and draw it, yeah. Consider that 4 legs are shrunken into 2 legs so that you can represent in a plane. At least you can show, you can draw the free body diagram of the chair. So free body diagram of the chair. What is free body diagram? It is a diagram of the body where forces are shown. Okay. If you go to in engineering mechanics, the best book is what? Dash. Timoshenko, who is called as the father of engineering mechanics. So University of Michigan, then Stanford University. He is called father of engineering mechanics. There is no dispute about that. So according to him, you go and see what is the definition of the free body diagram. Free body diagram is a diagram of a body where the supports are replaced by appropriate reactions. See here, this particular chair is in static equilibrium which is constrained, or you can replace that support by constraints. Now the constraints on the body is replaced by appropriate reaction. So this chair, without this the floor, what would happen? There is no floor. If I leave it, what will happen? It will drop. It will be falling. It will have a free fall due to the gravity. So the constraint is the floor. The constraints are replaced by appropriate reactions. Please understand, appropriate reactions. What is the reaction that is given by this floor? That you have to represent. But one of the important thing as I go around found that is free body diagram should not compromise its geometry. When I say a chair, you should not represent the chair by a block like this. Then how will you distinguish between a block and a chair? Chair is chair. If I say that a human body, I ask you to draw the free body diagram of a human body, you cannot say that this is a human body. Imagine this as a human body. No. Conserve its geometry. If it is a ball, keep it as a ball. If it is a chair, I don't want you to have a very elegant artistic work, but it should be a representation of the geometry should not be compromised. So let it be the chair, and you have active force W, and you will have the reactions from the floor. Then that will be, if I say it is a two-legged, this thing it is W by 2 like that. Of course here it will be W by 4 because you have 4 legs. So when you draw the free body diagram, show the active forces and replace the constraints. If it is a normal chair like this, when you want to show the chair, it is on the ground. This is a constraint. This constraint is to be replaced by appropriate reactions. Now I will do the same chair, I will butt it on the floor, against the wall. Now it is resting on the wall also. Then what will be the free body diagram? So you have to show the reaction, interaction of force interaction between the wall and this as well. Okay? If you take an example of the ladder problem, ladder resting on the walls, vertical wall and the floor. This is your popular ladder problem, where you have to show, if you want to draw the free body diagram of it, you have to show this, the reactions coming out of this. So you will have an active force, that is W. The constraints are to be removed, not at free will. It has to be replaced, the constraints are to be replaced by appropriate reaction. There only the knowledge of appropriate reaction is there. Suppose it is a frictionless floor, then the reaction will be always perpendicular to the surface. If it is a floor with the friction, then it need not be normal to this, it can be at an inclined position. So that is what meant by the appropriate reactions. So there some detail or knowledge about the kind of force interaction between the bodies is a must. So when it is a frictionless surfaces, the reaction will be normal to it. If there is a friction, then you have to apply your mind in what direction it will tend to move, then your reactions will be like this. So your R1, R2 will be there. So I cannot draw this R2 like this in this direction because this will tend to slide in the opposite direction. So this will be always in this way. So a knowledge about the friction, how it will act is important. We simply remove the definition that it is a frictionless flow. So you have to go back and see this engineering mechanics principle to reinforce your idea about this. Now, how to solve this? How to find out the reactions? Then bring in theorem of three forces. Okay, without theorem of three forces, I cannot solve this. So all these are what you have learned in engineering mechanics must be brought in. So theorem of three forces says that if three forces are to be in equilibrium, they must be in the same plane. There are three conditions. There are three conditions for three forces to be in equilibrium. They must be in the same plane. Their free vector should form a closed triangle. Third condition is that they must be concurrent. They must meet in the same point. If we extend this three, they must meet in the same point. If they are not meeting in the same point, then it's not going to be in equilibrium. Okay? So, theorem of three forces is a must. That will be used here also. They are just, whatever you have learned in engineering mechanics, that will be used here. So, just to review it. You all know that very well, but you have to review it. Bring back here to live to solve the problem. Now, how to solve this problem? I have arbitrarily drawn this. Suppose I have a frictionless wall. This force will be normal, like this. This W will meet here. So the reaction force is very well known that it must pass through this point. That's how I solve this problem. The theorem of three forces, if it is a frictionless wall, then the reaction will be normal to it. So this R1, W and R2 must meet at the same point. Must meet, they must be concurrent. So I can say the intersection of W and this. So this must intersect here. So your friction should be sufficient so that it can tilt itself and pass through this. If it is not sufficient enough, this will not be in equilibrium. Okay, bring in theorem of three forces. Now how to solve this problem? So you draw the free body diagram of each link. So draw the free body diagram of the piston. We know that there is a force P which is acting. If I assume that the friction between the piston and the cylinder, the supporting surface is very, very low, negligible. They use a Castrol or servo lubricant so that the friction is very, very low. Then I can say the reaction will be normal. So this is your reaction force. Instead of calling this as a reaction force, I can simply call it as F. But I use a notation for convenient. I call this as F14. When I say F14, it is the force applied by 1 on body 4. Applied by body 1 on body 4. That is the meaning of this notation. If I reversed it, F41, that means the force applied by body 4 on 1. That is the reaction. Okay? So this is F14. This is the notation. It is followed in this by Martin. We will also follow that. It's very convenient. Nothing wrong in this. Now, this, you have a reaction coming from linkage 3 because that is also connected to it. That is also constraining it. So the constraint is there. What is the direction and all this thing we do not know. Let us draw this. this will be force applied by body 3 on body 4. So that is the free body diagram of this. Similarly, if I want to draw the free body diagram of linkage 2, I will have the reaction force from here applied by 4 on, applied by 4 on 3. You see the change in the notations, F43 and F34, they will be equal in magnitude and opposite direction. Similarly, here you will have a force that is applied by 2 on 3. Then I will have a free body diagram of this linkage where I will have F32 applied by 3 on 2. Then I will have a force F applied by 1 on 2. Then I will have an external torque acting on it. That is the holding torque. Okay. So I have to draw the free body diagram of the 3 linkages and solve for, where the P is known, use the various engineering mechanics principles that you know, then solve for the magnitude and direction of each force, then you will find out what is the holding torque T. So that is our job in static force analysis. Okay, we will